Okay, so we are now working on composition of functions. And before working, like going through the steps, let me give you a short example of where can I think about the composition of functions in the real life, because we do need to bring in math to life also. We had already discussed about the functions of a baker who bakes the breads and uses the flour and other things like the baking soda and the sweets, etc., whatever are the ingredients of a bread. He uses those as an input and then processes that with the baking processes. Finally, the end product is the bread, which is the output of a single function. But if you will think about the input over here, which is the flour, is actually not itself the raw ingredient. It's itself an output of the grounding process. And the grounding process takes the wheat as an input, processes it, and then brings it in the shape of a flour. That means we have multiple processes or the functions going on in the real world. And we need to think about those all composite functions. I'm now using the word composite. Composite functions will help us to think about multiple steps of processes or functions happening in the real world. And that's the study when we will think about the same processes in one place. We are combining the functions. And as an example, as another example, you can see the whole thing over here depicted in multiple processes where we started with the raw material. I will consider this raw material over here in the very beginning as an input or the raw shape and input for which function? The function that's happening at this stage. Okay. Specifically in this process where the worksmen in a workshop are using these inputs, which is the aluminum, the copper, and all that stuff, taking those, and then with that specific input, what did they do? They performed an operation. Let's name that operation a G of whatever was the input, the copper, and if I will consider that input as an X, so the G of X is the process that converted the input of these raw material, processed it, and then changed that to the output, which are the basic nuts and bolts and these ratchets over here and these batteries or whatever coils are required to build up a car. So all these things are the output for the function G. Then after that, this output is considered, now I will use another color over here just to highlight, this output is taken as an input again. Where is it taken as an input? This is a final product from the first factory over here, which turned the raw material to these tools. These tools and the basic required equipments will become now the input of the next process. So keep it in mind that this input over here, which is actually the g of x, that's how I named it. Now this g of x is taken as an input for the next function. What's the next function? Next function is happening over here in this factory, which is in a way the BMW factory processing all those equipments, let's say using the function f of x, which is in fact, if I will consider x over here, this x is actually in terms of g, the earlier process, g of x. So g of x is taken as an input here, and with that input, the BMW is applying their processes and convert with that process all those equipments to a luxury BMW. And that is the process output, f of g of x, explained by saying g of x was the input for the function f for the factory, which is the BMW workshop or the BMW industry that took g of x as an input from here, which was a function applied to these basic raw material, and that's an example of a composite function. Now, thinking about the same multiple things in really simple mathematical terms, we can think about here. We had initially a group in this given mapping. A mapping diagram is shown over here. And in this mapping, we have multiple values of x, and we applied the function g on those values. So I should say that each of the numbers over here is representing g of x. If x is a 4, then the g of x is a 7. Similarly, if an x is a 7, then the g of x is 10. So every number input has an output, a unique output in the g of x mapping, which then is taken as an input for the function. And for every single function or every single input, which is a middle input somewhere over here, we have for a 7 an output as a 14, for 10 an output as a 20. And for 13, so on, we can keep on going and point out which inputs are converted by the function f into this final product. Thinking about the BMW factory is another way of thinking about the multiple processes. Now, what's happening here? If I will try to think about this 14, where did it start? It started from 4, converted to a 7 by the g of x, and then finally the function f of x processed on that and then made it a 14. I can claim that this 7 is here a g, not an f. Let me correct it. It's a g of 4, which is a 7. And then that g of 4, we took that g of 4 and applied the function f on that. So f of 7 became what? A 14. Whatever is the mathematics going on behind that, we are just looking at the mapping now. So if I think about this 7, what's that 7? That 7 is actually a g of 4, which is a 14. So this is an expression where I have used the composition of functions. Thinking about that, we can definitely figure out what will be the f of g of 13. F of g of 13. Here, I should actually start with the 13 over here and then think about what the function g will do to the 13, how will it operate it, and then for the next process, this 16 will be processed by the function f converted to something like over 32. And how can I put this whole composite function in action over here? So we will take, first of all, a 13 from here. This 13, I will take this and operate it with the function g. And you figure out in the class also that g is actually adding a 3 to the function input and then turns that to a 16. Now this 16, I took this and I will use the function f as a 16. It converts to the 32 with the operation provided in the function f over here. So function f converts that whole thing, the 16 to a 32. That's how we can think about the composite functions in terms of the mapping. Then we will think about, so what's the right choice before moving towards the next thing? The right choice over here is the C. Having that said, think about if you don't have the mapping, if we have the function table. This table can be explained like here we have again two functions, f of x, and there is another function, g of x. So we are not now thinking that x was the first thing that converted to f of x and then operated with the g, it converted to g of x. No, that's not the case here. How can I claim it? How do I know if it's not the case here? Reason being, each of these is taking x as an input, f of x, and g is also taking x as an input. So here I can simply claim, let me zoom it in a little bit over here, and then we will try to analyze it also. Here we can claim that this f of x over here is actually f of -2, which is equal to a 4. And then this one over here, the other function, the g of, let me take the other pencil to differentiate these. So g of -2 is equal to -3. Both are taking x as an input. So it's a little bit tricky now. If we want to check over here, if we want to check what will be the f of g of 0, keep it in mind, we will always start from the inner function and we will check, we will try to find out its value at the first input. And first input is 0. I will search for the 0 in the column x, which is 0 here. And then I will think about the function which is mentioned inside the parentheses, which is a g of 0. These tables are going to help me. Where is the g of 0? G of 0 is mentioned over here, which is a -1. So that tells me the inside stuff over here for f of g of 0 is going to be a -1. So f of -1 is something that I'm looking at now. And f of -1 can be found over here. -1 is available. And I do know if I will apply the function f on -1, that will give me a 1. So what's the final output for that? 1. So my correct choice that I will pick over here is C. That's how we will simply solve the composite functions using a table. Then there are some other steps also which we can use algebraically to solve these. Here I will share the process in another video. Hope that will make sense. And goodbye.